A function is said to be one-to-one when if the outputs are the same, this indicates that the inputs were the same. That is, if f of a equals f of b, keeping in mind that f of anything means a y value, then a must equal b. In other words, the two values that you actually plugged into the function must have actually been the same. If a function is one-to-one, then its inverse will also be a function. Sometimes we restrict the domain of an original function so that it is one-to-one, thus making its inverse a function. The horizontal line test is a test that's used to determine if the original function is one-to-one, and thus the inverse would be a function. A function is one-to-one if and only if any horizontal line passes through the graph at most once. So here, let's look at these two graphs and determine if they're one-to-one. This one, we see if we draw a horizontal line, it crosses once here and twice there. So this particular function is not one-to-one. Okay, we can see visually here what happens and why it's not one-to-one. We see that we have a single y value, in other words an output here, but we have two different input values, in other words an a here and a b there, and we can see that a and b are not the same thing, giving us this one y value here. So not one-to-one. The next example over, if we draw a horizontal line, it crosses once. Horizontal line crosses once. Any horizontal line that we draw would only cross once. So this function is one-to-one. We mentioned in the definition that sometimes if we have an original that is not one-to-one, then to create an inverse that's a function, we sometimes restrict the domain of the original. And I want to show you what I'm talking about here. Think about this first example that I had in blue that looks like a parabola. It's not one-to-one, and so if I took and found its inverse, the inverse wouldn't be a function. But if I go and I draw a similar graph to the original, but I restrict its domain, so in other words, only basically here look at half of it, look at only x's greater than or equal to 0, we see that that particular function is one-to-one, because if we went and drew a horizontal line, it would only cross once. We also notice that that particular function would go through every single possible value of y. And so restricting the domain really doesn't affect what the outputs are going to be. If that's the case, then we can restrict the domain here on the original, and then that way when we took the inverse would be a function as well. Imagine if we did sketch the inverse, it would end up looking something like this. Okay, and if we thought about that being a function, we could see that it was, because for each x that you have here, you would have only a single y up above.